Hello, my name is Ian Pena, and this is Physics 2212, Lab 4 Circuits. So the purpose of this lab was to predict the behavior of circuits with resistors in parallel and series circuits, as well as measuring the conventional current and potential difference within the circuits. So we used Ohm's law, which says that the potential difference is equal to current times resistance, as well as the loop rule, which basically says the potential difference is summed up in a circuit is equal to zero. Um, the current conservation principle, which basically says that the current within an isolated circuit will remain constant. Uh, to preview some results, we found that the predicted value for the current within the circuit would be 0.02041 amps, and the simulation provided a value of 0.02 amps. And using the simulation again, we found that the 47 ohm resistor would have a 48 ohm resistance, and the 100 ohm resistor would have 102 ohms of resistance. The wire would have a 0 ohms of resistance, and the ammeter will have 0 ohms as well. So the assumptions that we used to perform this lab, we assumed that the ammeter had negligible resistance as well as the wire. And then within this experiment, the system would be the circuit and the surroundings would be everything else. This is an image of the circuit created in lab. Um, Here's our calculation of the current within the circuit. And when the ammeter is flipped directions, then the sign will also be flipped of the current. So these are our models provided by the simulation. The ammeters show that it is 0.02 amps running through the circuit, and the here is where the voltmeter shows the voltage at this point within the circuit. So our model, this graph here, shows that the sum of the potential differences of the circuit will be equal to zero. Um, and then providing a parallel uh, divot right here at the 100-meter resistance shows that actually a current of 0.06 amps runs instead of through the resistor through the ammeter. This is the model of the RC circuit, which basically we had a bulb of 10 ohms and 20 ohms and a capacitor. So when we first connected everything together, we would see the light bulb shine bright, and then as time went on, it would get dimmer and dimmer until it turned off. So basically what's happening is the capacitor is being charged, and we found that through numerous measurements, we found it to be roughly around 6 seconds each time for the capacitor to charge. And then when we connected, after the capacitor was charged, when we connected it directly to the light bulb, we also found for the light bulb to be bright and eventually dim down until it turned off. And we also found that to be roughly around 6 seconds, which agrees with our model calculations provided by the simulation. So the sources of error for this lab, basically in real life, the battery might have a little resistance as well as the wires as well as the ammeters. Whereas in the simulation, these did not have any resistance to um, the circuit. And another thing too, like the batteries used in lab, they may not have been in the best condition. They may have been, used for many years and may have not been charged as well. Or maybe the wires and bulbs were maybe a little faulty as well. Um, but those are just some errors. The rounding errors that account for the 47 resistor having a 48 ohm uh, resistance. That's just errors due to rounding provided by the simulation. So the what if and why. If what if you're doing this live in real life? How does how does the actual ammeter uh affect the circuit than an ideal simulated ammeter? So like I said before, an ideal simulated ammeter would have no resistance, and whereas in real life there's some level of resistance that would affect the current um, running through the circuit. What if we were doing this lab in real life and used a real battery to charge a real capacitor with no resistor in the circuit? With no resistor in the circuit, I feel like it would be a lot quicker, as the resistor is not drawing anything. So the battery would charge the capacitor a lot quicker.